Welcome to the solutions for problem set number 11. We're going to start by looking at some inductive sequences, arithmetic sequences from core 1. So, question number 1. A sequence is defined by A1 is equal to K, that's the first term is K, and then the next term is 2 times the last term minus 7. Just go back over again, this is telling us the first term, and then this thing here is the inductive relationship. This is the next term rule. So, A, write down an expression for the second term, A2. So, the second term. So, we're going to use this thing here, and I'm just going to notice that this is a 2. So the n plus 1, n must be equal to 1, because 1 plus 1 makes 2. So A2, the second term, is equal to 2A1, the first term, because remember we said this bit here is 2, so n must be 1, which means that this is going to be a 1, minus 7. But that's not enough to get us the 1 mark. We've actually got to put in what the first term is, because A1 is here. We've been given it. So A2, the second term, is equal to 2K, because K is the first term, minus 7. So that's our 1 mark special. And then they take pity on us now, because they say, show that the third term is this. So we know what the answer is going to be. So the third term, subscript 3. Well, if this is n plus 1, then n in this case must be 2, because 2 plus 1 is 3. So it's 2a2 minus 7. But of course we know what the second term, a2, is, because we just worked it out, so we can substitute. So it's 2, and the second term is 2k minus 7, minus 7. So just to make that obvious, I've taken that, because I know that it's up here, and I've substituted there. And I'm going to multiply out. 2 times 2 is 4, so it's 4k minus 2 times 7, which is 14, minus 7, which is equal to 4k minus 21. There we are. We have shown it. It has been demonstrated. And now we come on to the bit which may well catch some of you out. Given that the sum of a subscript r between 1 and 4 is 43, find the value of k. So this is a mystery to many people. It doesn't have to be though. You may recognise this sign here. This is the sum. So it's the sum of the sequence. In fact, it's the first 4 terms, starting at term 1, ending at term 4. First 4 terms. So what this is, shorthand is for writing, it's for writing A1, because that's the number at the bottom, plus A2, plus A3, plus A4. We stop at A4 because that's the number at the top, and they're telling us that the sum equals 43. So there's several ways to do this. We could use the sum formula, but since we've got A1, A2, A3, it's just easier to work out what A4 is and then go from there. So let's do that. So the fourth term is equal to 2 times the third term minus 7. So it's 2 times, now the third term is given to us here, it's 4k minus 21 minus 7, which gives us 8k minus 42 minus 7, which is 8k minus 49. So now what we can do is we can use this. So the first term was k, so that's our first term. Our second term was, if we just look back a moment, the second term was 2k minus 7. So we add that, 2k minus 7. So we've done that one, now we've done this one. The third term, that's this one here. That is 4k minus 21. And finally the fourth term, the one we just worked out, is 8k minus 49. And all of that lot equals 43. When you're dealing with equations, don't forget to carry your equal sign on along. I've seen many times when people have forgotten that what they're dealing with actually equals something, and then they get to a point and they don't really know what to do with it because they've forgotten there was an equal sign. Now, let's just simplify this. We've got 2k and 8k, that's 10k, so we've got 15k there. And then we've got minus 1, minus 21, and minus 49. So that makes... Now that seems rather strange to me. I think that's not minus 1, is it? That's minus 7. That's better. That makes minus 77. And it makes 43. So that means 15k is 120. And that's a good sign, because 120 is 8 times 15. So there we are. We found the value of k. Job done. We're going to a little bit of trigonometry now. So core 2 questions. So notice calculated should be in degrees. So the answers are going to be in degrees. Digress. Degrees. Now, first one. The trouble with these is they can be quite intimidating. But what you've got here is, well, it's not a quadratic equation, but it's like one, isn't it? You've got 2 brackets, multiply the brackets together and you get 0. So, one of those brackets could be 0, couldn't it? So 1 plus tan theta is equal to 0, which means that tan theta would be equal to negative 1, because I've subtracted it, and then theta would obviously be the inverse tan of negative 1, which means that theta would be equal to minus 45, and that's obviously in the range there. Now, we've got to make sure that that's not the only solution, so we're just going to do a quick sketch of the graph. So the tan graph looks like this, and that's 90, and that's minus 90, and then it comes up, and of course that's 180, and here it would do that, and that would be 180. So that's our range. Now, tan theta is minus 1, so minus 1 is down here. So, actually it's probably not down there, is it? That's probably a bad place to draw it, really. Bearing in mind that we know that there's our minus 1 there, and there's our 45. That's the one, minus 45, sorry. That's the one we just worked out. So we've got another solution up here. And it's 45 back from this point, so it's 180 take 45 to work out what the number is there. So 180 take 45, which is 135. So our other solution is 135 degrees. So that's that one done. Now for this one. So we've considered the first bracket being 0, now the second bracket, 5 sine theta minus 2 equals 0, which means sine theta would equal 2 divided by 5, and theta is the inverse sine of that. And if you put that into your calculator, then theta will come out to be 23.58 degrees. And now we've got to check that there aren't any more of these ones. So here's our sine curve. So the sine curve does this. And remember, we want it from minus 180 to plus 180. That does vary. And we've just done sine theta of 2/5, so 0.4, so that's sort of about here, isn't it? And there's our 2 solutions there. This one's the one the calculator gave us, 23.58. And this one here, well, that's 23.58 on. This is going to be 180 minus 23.58, which is 156.42. That's our other solution. So 156.42 degrees. So that seemingly innocuous little question had 4 distinct solutions. Onward and upward. Now we've got a different range here. We're still in degrees, and a different equation. Now, there's several ways to do this, and there's no nice way of approaching these sorts of equations. The only thing you can rely on to help you is experience, and the way you get experience is by trying them, looking at the answers, building up a bank in your memory of different things like this until you start to recognise what you're being asked to do. Now, what I'm going to do is I'm going to use an identity here. There's clearly, part B, they're going to expect something a bit more tricky. So this is the identity. Tan x is sine x over cos x. So I've got 4 sine x is equal to 3 times sine x over cos x. Now ideally I would want to reduce it just to sine, cos or tan, but not always. So what I'm going to do now is I'm going to multiply the cos x across. So 4 sine x cos x is equal to 3 sine x, and then I'm going to subtract the 3 sine x across, minus 3 sine x, and then that equals 0. Notice I'm not losing my equal sign, very important that, and now I'm going to factorise it. Notice it's a common factor of sine x. So sine x, and then I've got 4 cos x minus 3. Now, you might ask me, how did you know how to do that? And there is not a nice answer. The answer is very clear. You have to do enough of these so that you start to have some ideas, and when you look at that, you might have several lines of attack. This is, I think, one of the places where you can't follow a set of rules very easily. Unlike a lot of mathematical problems in exams, you have to have some experience here of trying to solve these problems, and even then you'll come up against them that'll take you a while to solve. Right, so let's go for, first of all, so sine x could be 0, that's our first possibility. And we'll just consider sine x equaling 0. Well, that means that x is the inverse sine of 0, which gives us, if you type that into your calculator, you should get 0. And if we consider that on a graph, the sine x graph looks like this. You need to know these graphs like the back of your hand. And again, that comes from practice. So there's sine x equals 0. So we've got that one. So you can see there's another one at 180. So 0 degrees, 180 degrees. Now, you consider the 360 there and dismiss it, because if we look at our range, it's less than 360. 360 is not included. Now our other option, 4 cos x minus 3 equals 0, which means that cos x is 3/4, and x is the inverse cosine of that. And when you type that into your calculator, x turns out to be 41.4 degrees. But is that the only one of those solutions? So now we draw the Cos graph. So the Cos graph starts at the top and goes down and then comes back and goes up again. So there's our 180. These are our 90 marks. So 3/4, that's about here. So we just go across and you can see there's a solution there. We know that one, that's 41.4. It's that one we want there. Now, this 41.4 is the gap from the vertical axis and that point there. So we're going to come back here. It's that gap there. So it's 360 take away 41.4, which leaves you with 318.6 degrees. And so that is the other solution of this one, 318.6 degrees. So, I will reiterate what I've just said. If you want to be successful at these, and I would recommend that it's worth trying, I mean there's certainly a lot of pleasure to be got from doing them, you need to practice, but you need to be aware that certainly when you're starting out, don't struggle with it for ages. Have a look at the solutions. ask somebody. Don't just sit and stare at it for hours expecting somehow that you are going to magically be able to do these. You have to go and find some answers and build up this memory bank of how you can attack these problems. Hopefully you'll do that, and you never know, you might bring me on today one that catches me out.